Hey, this is from Unit 5, that extra practice packet before quiz number 9, page 3, the bottom problem. So a particle moves along a line at time t, where time is between 0 and pi. Its position is given by s of t for the position function, negative 4 cosine t minus t squared over 2 plus 10. What is the velocity of the particle when its acceleration is 0? So we're talking about position, and they bring up velocity and acceleration. So I need to know the relationship between position, velocity, and acceleration. And I'm going to give you the answer, but let's look at what we're looking to do. So first, let's find the velocity. So I know that's the derivative of the position function. So derivative of cosine is negative sine, so it's negative 4 times negative sine is positive 4 sine t. Derivative of negative t squared over 2 is negative 2t over 2, which is just negative t, and the derivative of a constant is 0. So there's my derivative of the position function, which is velocity, and I now know the velocity. I want to find acceleration, because eventually we want to find that equal to 0. So derivative of sine is cosine, so it's 4 cosine t. Derivative of t is 1, so 4 cosine t minus 1. Now, let's find out what time is when acceleration equals 0. So, hey, add 1 to both sides, divide by 4, use my calculator, and I get time equals 1.318. And I'm going to show you how to do this on the calculator. Okay, so that's the time when acceleration is 0. Great. It's not what the question asked. The question said, what is the velocity of the particle at time equals 1.318? Because that's when the acceleration is 0. So now I come in and I put into my velocity function, which is the first derivative um, up here. And so now I put that in and I get 2.55. All right, so you might have made the mistake and got 1.32, but let's take a look at that right now. So when I come to my calculator, I got a lot of things graphed right here, but there's my original function. So y2, and I'll go back, just remember that's my original function. This is my derivative, and I need to, oops, I messed that up. So this is good practice for the calculator. This is my velocity function. That's the derivative of the first one. Let me take the derivative of this. So that's my math button. Choice 8 is end deriv. So I'm saying let's take the derivative with respect to the first derivative, which is y2. So I hit vars, go over to y vars, function y2, which is choice 2, and I'm going to graph it. So this is x equals x. And I had something else typed in there, so I got to go and delete that. So delete the 0.25. So this, I'll rewrite that 0.25 on the next one for y4, because that's the when it equals 0.25. So 0.25, that's the 1/4. Okay, so I'm going to solve this. So this is my position function, blue. Red ends up being my velocity function, and the third one is my um, the last derivative. So I actually want to find out when, if we come back here, I want to find out when the acceleration, the second derivative, is equal to 0. So I can do that right now. Let's take a look at that. When is my second derivative equal to 0? And actually, I want to shut this last one off, because I'll show you what we can do with that at the end. So I'm going to find when my green function is equal to 0, and the original parameters were between 0 and pi. So there's the position function. Here's my velocity function. All right, I just paused it because it was taking forever. But so here's my green function. I want to find out when this is 0. So in between 0 and pi, that's going to be somewhere around here. So let's come back here and second calculate the 0, which is choice 2. And I want to just toggle between the functions. There you go. So left bound, hit enter, right bound, hit enter. Oh, that's not going to work, so it's going to give me an error message. I think I went too far to the left. Let's try that again. That gave me an error message. So I can calculate the zero of the second function, excuse me, the third function, which again is green. This is the second derivative. So second calculate, choice 2, the 0 of the green function. So left bound, I need to go to the left of 0. That's what I didn't do last time. Such a rush. So there you go. Now go to the right of the 0. Yes. And it should give me, still thinking, there you go. There's my 1.138. Now, how do I use my calculator? I want to find out when the velocity is 1.318116. So this is my velocity, this red function, y2. So now I go second, calculate the value, enter, and I go 1.318116, enter, and then I go to my red function, and there it is. That's my answer. 2.55486666. All right? Hopefully that one helps.